Then your hand.
You put the... That's all she was looking for. She was like, well, you took pottery online. Exactly. It was like art history. I think it's like pottery. Exactly. So she would want to take it.
All right, guys. Focus. Only positive energy. About linear and quadratic. What are quadratics? So the most common quadratic that we've studied is the parabola. So I'm just going to show you some pictures. So let's say I had a parabola and I had a line. So when we were doing two lines, we said that it's possible they don't meet, or it's possible they cross once, or it's possible they have infinite. So the possibilities for two lines is one solution, no solutions, or infinite solutions. What about a line and a parabola? Well, is it still possible to have no solutions? Yep. Is it possible to have one solution? Yeah, it can still touch. No, put that away, please. Is it possible to have more than one solution? Yeah, it's possible that also a line and a quadratic touch twice. And so you might see today that we have some things that have two solutions. Which, if you think about it, if we did quadratic formula, doesn't that give me something with two solutions? We're going to do one that involves factoring. Then you can get into things. Another quadratic that you might see is a circle. Did you guys know that that was a quadratic? Because it has an x squared. Okay, so it's kind of the same deal with circles and lines. It's possible they don't meet. It's possible they meet once. If you don't want to draw it, you don't have to. It's the same deal with any quadratic system, or it's possible they meet twice. Ooh, what does this make me think of? What about a parabola and a circle? What's the most that could have, do you think? It could possibly, if I had a parabola and a circle like that, it's possible it could meet 4 times or less. Anyways, the bigger deal here is that intersection, we found an x and a y of lines. When we're finding possible quadratic linear systems, it's possible we're going to get 2 x and y coordinates. So let's do an example. Let's find the solution of y equals x squared minus 5 and x plus y equals 1. Okay, so now just so you guys understand, x squared, we could graph these, like you could, if you want to look on your graphing calculator, you could graph x squared minus 5, it would be a parabola. Couldn't you move this x to the other side and graph that and see? Okay, so that's a good way to check answers right now, and honestly, if this is on the calculator section of your SAT, put it in your graphing calculator and do it that way, okay? But I'm going to show you algebraically how you would do this. What, if I'm thinking of solving how we did before, what do you kind of want to do? Substitution. See this y here? Could I put it down here? Let's do it and see what happens. So now I have x plus, what would go in that spot? X squared minus 5 equals 1. And since I have a quadratic, my possibilities for that are always quad formula and factoring. But what needs to be over here? A 0. So I'm going to move everything over here. I'm going to rearrange it. Subtract that 1. And then I'm going to put it like in standard form. So I would write first x squared plus x, what do I get here? Minus 6 equals 0. I found that I really like to use factoring if possible. I know many of you don't like factoring, but if possible, I do like to use factoring in zero product property. And I notice this is factorable, because aren't there some numbers that multiply to be -6, and then when you do their outers and inners, they add up to 1?
Yes.
What are they?
X plus 3, x minus 2.
X plus 3 times x minus 2 equals 0. Okay, so what if you're like, I want to use quadratic formula? Quadratic formula will work. You're going to get the same solutions. Set them each equal to 0. What do we get over here? X is equal to -3. Remember, these are ordered pairs, guys, right? So let's go ahead and plug it in up here and find y. So if y equals -3 squared minus 5, let's use our brains, not our calculators. 9, right? Minus 5 is 4. So one of the ordered pairs is the point -3 and 4. I have x minus 2 equals 0. What about on this one? X equals 2. Plug it in. And so that would be your two solutions. This one meets twice. How are we doing? Okay. So that's all I wanted to show you.